welcome to this installment of our plant engineering video conversation. I'm your host, Amara Rozgis, Editor-in-Chief of Plant Engineering, and I've connected with Christin Bush at Schneider Electric. This is part of the Maintaining Your Plant Floor Edge series, which focuses on many different things. Thanks for joining me today, Christine.
Thank you so much, and happy Friday. I'm glad to be here with you.
Awesome. Well, here's some background before we get into the details so you know who Christine is. Christin Bush is the Robotics Center of Excellence leader at Schneider Electric in Raleigh, North Carolina. Christine's passion and expertise lies in industrial automation. She's worked in robotics, material handling, and in batching systems. She's managed many different groups in both technical and sales applications. So, Christine, you have a really broad background. Let's start with some of the basics here. What are the key benefits of digital twin technology, and how is it driving the next generation of manufacturing?
Digital twin technology is really taking us a step forward in design concepts in manufacturing. It gives us the flexibility to try before we actually implement. Therefore, we're removing any kind of obstacles that in the past we may have had to stumble through with moving conveyor sections to another part because of an I-beam in a brownfield location. Also, are there any kind of bottlenecks in a system? So digital twin technology is really driving us to be more energy efficient and resilient from a design perspective.
Well, then, how can manufacturers implement digital twins beyond installing and commissioning to operate or optimize their operations?
There are many additional ways that we can use digital twin beyond that installation and commissioning perspective. Those are going to be the two main areas of utilization for a digital twin today. But as we continue to evolve digital twin technology, we're going to be able to use it in operation so we can see how things are performing from a manufacturing perspective. If there is an issue in the manufacturing perspective, we'll be able to see it in the twin technology. So that's going to enable maintenance to be able to do more and to resolve issues faster than starting from scratch and not seeing something. They will be able to look at history through a twin and actually see the process move so they can take time back to find out, oh, that is exactly the event that happened that caused the issue. This is what I need to go fix. The other area is just in the modernization process. As a facility needs to be more efficient because we're all being judged on revenues through our manufacturing processes, it's can I think of doing something in a smarter way? We can take that, put it in a digital twin to actually see if we're going to get the results that we expect instead of just going and trying and spending money without an unproven upgrade in a process. The other thing, and this is very exciting for me, is to actually use the digital twin as a training tool. So all of us are going to be bringing in new operators, new maintenance techs, new engineers. So today we put them behind a screen and we may watch a video, but what if we immerse them in a digital twin experience? So they're virtually manipulating the manufacturing process, gaining those skills in a virtual arena, and instead of the trial and error on the process line. Because I've been there, and plant managers don't like any kind of snafu on the manufacturing line. So and able to give them that experience virtually, I think is going to be the next best thing for manufacturing.
So it's really a try before you buy kind of situation.
Oh, definitely. Definitely in a lot of many ways.
Got it. So what are the main challenges then with implementing digital twins? How can people overcome them?
So the main challenges today with digital twins are going to be the time to do the physical replication of the machine, the manufacturing floor, the expertise to actually do this, and then the return on investment for spending the time here. But as I've indicated, this is time that you're going to be able to use and reuse and help modernize your processes. So I would say, can you really afford not to go here? Yes, there is going to be the overhead. With the time, you're going to have to make an investments with a team that is focused on the twin technology. But the return on investment is going to come again from just manufacturing efficiencies, and efficiencies with training your personnel. So I would say, can you really afford not to make an investment in digital twin?
Okay, that makes sense. What about like, do you have any customer stories or explanations of how this has worked in a specific project?
Yeah, so we were working with an OEM a couple of weeks ago, and they wanted to utilize one of our Delta robots. They had a very succinct form factor for their machine size, and they didn't take into consideration the entire envelope of what we could pick. And we were able to show them with the twin that we were actually going to hit the side, one of the walls of the machine. So we used that to show that one, there was going to be a hit inside the envelope, and two, they weren't going to get the efficiencies with the robot. So we downsized the robot that we picked. We were able to show them that the picking envelope was more efficient, and it allowed them to meet the throughput that they wanted without the obstacles. I think moving forward, another use case is going to be warehousing, especially with 3PLs that design buildings. They are moving into this digital twin technology to show that implementation of conveyor sections in unique ways for their customers. They will be able to show the conveyor layout. They will be able to show the product flow challenges and bottlenecks to show that, okay, with the throughput, this is the one area you've got three conveyor sections moving into one area. Could be a bottleneck or a jam situation with boxes moving through the warehouse. I think from a manufacturing perspective, another thing that I think digital twin will have an impactful result on is just the fact of modernizing brownfield locations where they want to have more throughput, and they do have miles and miles potentially of conveyor, and you can, in a digital environment, reconfigure the floor, and realize that maybe they can get additional throughput through a brownfield location rather than going to the expense of a greenfield location. I'm not going to say greenfield should not be the right path, because there's also applications in greenfield where it helps you optimize the layout there as well.
All right, well, keep your crystal ball out. We're looking at the
Okay.
future here. What do you foresee over the next 5 years in terms of full adoption, impact? What does that look like?
I really feel with digital twin technology that, from now into the next 5 years, that I think every manufacturing location, any warehouse, or a DC location is going to be taking advantage of digital twins. It's just a must. Because we're being challenged every single day to be more energy efficient, more sustainable. Time is valuable, and these digital twin technologies are going to allow us to do so much more in a virtual environment, instead of making mistakes physically. We're going to be able to pull those out with this twin technology, and we'll be able to increase throughput in the manufacturing space, in the warehouse space.
That all makes sense. Well, that was Christine Bush with Schneider Electric talking about several topics related to digital twins and the many challenges and opportunities surrounding them. Thanks, Christine. It's an absolute pleasure to chat with you.
Thank you so much. I appreciate your time as well.
Excellent. Well, for more information about digital transformation, digital twins, and similar topics, visit Plant Engineering at www.plantengineering.com. That's it for us today. Thanks and goodbye.